Hello, in the last tutorial I showed you how you can create this room with a spline that automatically generates if you move the points around this. And in this tutorial I'm going to show you how you can expand on this to increase some height to your room by having a variable in your blueprint that you can increase and spawning additional walls, all with the help of the PCG tool. If you didn't follow the last tutorial, I will create a generic node that you can use in other PCG graphs as well. So you don't necessarily have to have seen the first video that I created. So I can increase this. I can also increase this to a very high number, like 1,000, which will take a while to generate, but once it's done, it creates a very tall building. And going back to 1, we can jump right into the code. Okay, opening up the PCG graph that we created last time, so the PCG room, we can see that what we need to do is add a node between those two connections that multiplies those points and copies them upwards. And we can do this by creating a new blueprint class, which is a PCG blueprint element. And the PCG blueprint element are all those nodes that we can see here. For example, difference node, the transform points, and even the static mesh spawner. However, some of them are C++ versions of them, so you won't necessarily find them in the engine folder as blueprints. We are going to call this BPCG stack wall stacker. Wall stacker. And if we open this up, we can change a couple of basic things. The first thing we're going to change is checking this checkbox to expose it to a library. This will make it so that it appears in the list on the left side. And we are also going to change the category to be room. If we hit compile and save, we should now see it in our PCG under the category room, the BPCG wall stacker. You can plug it in here. And what we want to also make sure is that we put points into here and not anything. And we can do this by opening up the blueprint again and adding inputs and outputs. One input and one output. We call in and out. In and the other one out. And we set them to be a point. And once we do this, they should become blue if we also disable the default input and output pin. Now we have blueprints that we can connect, where we can connect those two pins together. The other thing we are going to need is two variables, one for the height and one for the offset of the mesh, so the height of the wall. One is an integer, the other one is a vector, which we call wall amount. And the other one is the offset, which we just call offset. As for the default values, we are going to set them to be, let's say, 4 for the wall amount and 400 for the mesh size. And with this done, we can jump right into the code. We need to override one of those functions, which is the variable loop body, which is a function that takes all the input points and can output multiple points for each point, which is exactly what we want, because we want our starting points and then stack them upwards horizontally. There are also other types of loop, for example, the point loop, which takes one input point, changes something about it, and outputs it. The iteration loop body, which is basically just a normal for loop that you have. So you have an last index and you go from the first one to the last one. We are going to use a variable loop, and so we are going to override the variable loop body. In here we have a couple of things. The output that we're going to use is, for the output, we are going to promote this to a variable that we fill later, so the array, and we call it output points. And we also need a for loop. A for loop that goes from 0 to the wall amount, so how many walls we want, -1, because we start at 0 and not 1. And if we wouldn't subtract 1, we would have 1 extra wall, which we don't want. We have this for loop, and the next thing we're going to do is we are promoting our point also to a local variable to have an easier time. So we call this point, not paint, point, and connect those pins together. The next thing we're going to do is we are going to get the point and create a copy of it, copy point. This will create all the values of the original point, like the size and the density, and copy them to the new point. And before we forget it, we hook up the return node to the completed of the for each loop. We're going to copy the point on each iteration of the loop. In this point, we're going to set members in this point, which is the transform and the seed. As to why we need the seed, I will explain a little bit later with the problem that happens if we don't set the seed here. And now we need to calculate the new transform for the point, which we can do by breaking this pin, breaking the pin, which gives us the transform of the point. And from this transform, we break it and we make it. Make transform. And we are going to keep the same rotation and the same scale, and we're only modifying the location. Calculating the new location is fairly simple. We just need the old location and we need to add the offset to it. However, we are going to multiply the offset by the index. And since we start at 0, we also we won't add any offset for the first point, which is great for our use case. And once we multiply the index with the offset, we have to add those two together. Add. And connect them into the make transform and set this transform. Here I'm going to uncheck the seed to see what happens if we don't do this. And that's pretty much everything done, other than us needing the struct pin and adding it to the array of our outputs. Struct add, and we are done with the for each loop. We get the point and make a loop over the wall amount. We calculate the transform, set it in the point, and add it to array, and then return the points. This alone won't solve all of our problems. We also need to do some basic stuff in this function, the execute with context. In this one, we need to actually call our variable loop. And in order to get to the point where we can call this, we need to do a couple of annoying stuff that I hope they change in the future to make it easier. But as a little workaround to make it easier, we can go to our room, get the caller node, set point caller, double click it, and here we can navigate to the execute with context, and just copy paste all of this. We now go back to our graph and paste this into this one, hook everything up. So this to this, remove the return node. And we are going to need to set the context to this context as well as this context. And the input to here. And right-click on this, correctly right-click on this, create a local variable. And now, just to test it out, we hit compile, save. Nothing is working because we are not displaying it. It's not working. I probably forgot something very important. This one is connected. This one has a wall amount of 4 execute with. Oh, yeah, of course. We didn't do anything in the point loop. We need to change it to a variable loop. Variable loop. Connect everything up to this one. Because we are not iterating over a single point and we changed the variable loop instead of the point loop. So hook everything up. And I also will briefly explain what the thing we copied actually does. But just to see if it works, we now have walls that are 4 tiles high. One thing we're going to do is we are going to our static mesh spawner in here in our PCG room, and in the mesh entries we are going to add a second mesh by going in here and here. This one has wall. Give me a second. This folder and Windows. And going here and here. What we can see is the problem I said with the seed, that every single point has the same seed that is in one column. So every row has windows randomly. But we want it to so that each point has a different seed, so it's not all the same. And we can do this by going to our wall stacker, and when we set the members of our point, in the flow control, in the variable loop body, when we set the members of the point, we can simply set the seed. And to get a random seed, we are going to look for seed, compute seed from position, and hook this up. Put the seed into here and the position into this one. This will generate a random seed based on the position, and since each point has a different position, the seed is different. And if we now compile and go on test level, we can see that our windows are randomly scattered around the seed and not in one column only. Now, you can stop right here if you want, since, well, actually you cannot stop right now. We also need to go into our room tutorial in our blueprint that contains the spline and PCG, add a variable, which is the wall amount, set it to, say, 10 by default. And now we need to get in our PCG again. Open this up. Let's make this instance editable, and in our wall stacker, make those two instances editable. In this one, we can now, if we compile everything, see the wall amount. And in order to get the wall amount from our blueprint, we are going to need the getActor property, which we need to put in the wall amount. So the name of the variable that we have here. And we are going to place this into the wall amount. Now, we should be able to control this with the variable, compile, and set to 7. And as you can see, we go up and down and have randomly generated windows. And now you can quit if you want, but I will go briefly into the stuff that we copied over. from the other thing. So if we go to the executive context, what happens here is that we essentially get all the inputs that our class has. So here we define one input that can have multiple data sets. And we get the inputs. Here we get all inputs that we have, and we loop over them. So if we put in multiple point data sets, then we are going to call the loop that we have here for each data. Each point of data, and not only one. We could also get the if we only get the first element, then we of this array, which is our point input, then we might run into a problem that we only execute our stuff on one of the point inputs. So we need a for each loop here to iterate over all the inputs that we have here. As for those points, we need to break them into PCG tag data, then cast them to spatial data. Spatial data contains some information of the position, and then we need to turn this back into a point from the context. And this is what goes in the variable loop, and the output of our variable loop is made to a PCG tag data, added to the array of output data, and then once we loop through all the elements, we are returning this. Yeah, that's pretty much all the magic, and not really something you actually need to know what happens, but you need it to get to the point where you get to the variable loop. You obviously can do a lot more stuff here than this basic stuff, so it's definitely necessary, but these couple of nodes here are something that is quite handy to get to the point of the variable loop. Another thing, as you can see, as I said, you can have multiple inputs here, and into this pin, we're actually putting in multiple data assets and not one. This is looks a little bit misleading, but we have this point here has 3 dots, which means it can be multiple data sets. And since we add multiple data sets here, it also keeps being multiple data sets. And yeah, that's just a little bit of unnecessary information. And you can turn them into one set of points by merging them into one set of points. Now those 4 would be one input point, and in our wall stacker we could only get the first input. Since now we have only one input that we pass into a function, but it's safer to do it with a for each loop, I think. Yep, that should cover everything for the tutorial. In the next one, I probably showcase how you can add a door to your room and at a predefined position, because it's pretty pointless to. It's probably pretty helpless if you can enter and leave your rooms. And I will also briefly do something about the roof tile, which you can, which you need to change a little bit of. In order to do the roof, you need to change a little bit of on the wall stacker. If you want to try it out yourself, you basically only change it in a way that you only return the top point and not all points, and then you use the wall stacker for the floor tiles. But I will cover this in a separate tutorial, since this one already took up, managed to get quite some time on the clock. So, hope I see you in the next one, and